An humanoid robot that looks like human being can be deployed into a tomato farm. What is it looking for? In front of the humanoid robot, it's just going to scan which of these tomato is ripe, which one is actually unripe. So basically, we use a color sensor that can actually differentiate between red color and green color. And by the time it sees red, it's going to plug it. And by the time it sees green, it's going to do what? It's going to leave it. Now, integrating AI into robotics for agriculture, we actually maximize food production in Nigeria and in the world at large. One of the things that inspired me at LH happens to be a very interesting electronics project given to me by my physics teacher. We are asked to manufacture an electronic gadget using a local material. A friend of mine that is currently an army officer called me during COVID-19 that they actually need to construct a disinfectant tunnel. Almost every company have run out of the disinfectant tunnel they have. Now said, Sam, I know you do a lot of robotics projects. What can we do to this? I know you can solve it. I said, I'm actually glad that you actually believe in me. And I proceed to the National Electrical and Electronic and Mechanical School of Engineering Army at Auchi. During my presentation to one of their captain, it was one of my greatest moment on earth.
What inspired your journey into robotics and electronics?
A lot of things actually inspired me to actually proceed further on robotics. I would like to mention few. One of the things that inspired me at LH happens to be a very interesting electronics project given to me by my physics teacher.
Okay.
So we have a challenge. We are going for a competition and we are asked to manufacture an electronic gadget using a local material. So I walk up to my physics teacher and he told me that I need to construct any of the gadgets I choose because I choose two gadgets, a standing fan and likewise a metal detector. So the available materials we have then happens to be just ordinary wood and electronic motor.
Interesting.
So where the challenge comes in is that we don't have any fan blade. So basically, at that point in time, we have to look into the laws that actually guide electronic, the fan blade. So at that point in time, we just make use of a roving sheet and we cut it into an Oxfam shape and we attach that to an electronic motor, about 12-volt electronic motor, and we place the electronic motor inside a very good carved wooden. So after that, we actually supply about 220 volts into it, and we have an adapter that steps the 220 volts back to 12 volts. And as soon as the fan starts spinning, everybody was very, very happy. But we have a challenge. There are two rotation of motors. We have clockwise and anti-clockwise. If it's moving anti-clockwise, that means it's going to be blowing backward. And if it's moving clockwise, it's going to be blowing towards the front direction. So at that point in time, that's when I learned the first principle of two direction of motor rotation.
Wow. Now that's very interesting. Yeah. So what was the project that you are most excited about? Because I know what you just mentioned, that was your first project, right?
Yes.
Yeah. So among all the projects you've done so far in robotics and electronics, which of them are you mostly proud of?
A friend of mine that is currently an army officer called me during COVID-19 that they actually need to construct a disinfectant tunnel. Almost every company have run out of the disinfectant tunnel they have. Now said, Sam, I know you do a lot of robotics projects. What can we do to this? I know you can solve it. I said, I'm actually glad that you actually believe in me.
Yeah.
So overnight, I have to see how I can construct or model a 3D design of that particular disinfectant tunnel. And a friend of mine actually helped me out. We work on it overnight. And after that, I proceed to design the circuit diagram in order to control almost all the sensors that will be in the disinfectant tunnel. And I proceed to the National Electrical and Electronics and Mechanical School of Engineering Army at Auchi.
Yeah.
And I called the aluminum person to actually follow the 3D design. And it did fantastic work. And after that, I proceed to actually attach those components to them. Actually, one of those components that actually amazed me most is actually the contactless, what do you call it? Temperature sensor. You don't need to move closer to the temperature sensor. Just place your hand in front of it. It's going to calculate your temperature.
Wow.
And at that point in time, we set a limit for the temperature sensor to be actually not to be above 35 degrees Celsius. And immediately your temperature is normal, there will be a speaker connected to that temperature sensor telling you to proceed to the next chamber where we have all the four gas that actually sprays all the chemical solution to disinfect all your body. And if your temperature is actually above, this particular speaker still tells you that you should exceed through the first chamber. So during my presentation to the one of their captain, it was one of my greatest moments on that.
Yes, that's a very amazing story you just shared right now. Yeah, and from what you mentioned, you talked about different electrical components and circuits and all. I know those things are under electricals, right? So how does electronics and robotics come together? Because I feel that this is the backbone of robotics. So how is electronics the backbone of robotics?
A, a very small baby needs to start crawling before walking. Likewise, in robotics too, you need to study different electronic components, ranging from resistors, LED, different types of electronic motor, being synchronous, brushless motor. We have thousands of electronic components. Transistors are there, microcontrollers are there. So whenever you study all these components, you can know which of the components you can use to build any type of robot you want to build. We can have different scenarios whereby different industry manufacturers can come in and tell us that they want to build different kind of robot. So if they come in and tell us they want to build different kind of robot, we need to look what are the electronic components that can actually perform all these various actions. So that's where we now sit down and now start put all those components together. The process of putting them together, we call it circuit design. So by the time we connect all those components together, we have a software to do that. We test what's the reaction of different components, starting from the power supply stage where we supply power into it. We have the control stage whereby the microcontroller communicates with different components. And after that, we have the output component, which happens to be the sensor. So after checking all this, we now look for different kind of 3D modeling designs that can be printed out on a 3D printer on how to actually build the structure. And once we put the electronic component on the PCB, we call it printed circuit board. Once we play that on the PCB, that's where we now connect all our motors, sensors onto the PCB. And by the time we power it, it becomes a robot.
That's interesting. Yeah, you just use your terminologies in your electronics and robotics, and from what I picked from what you just said now, would it be nice if we say that electronics plays the role of a skeleton in a human body?
Electronics component can actually work without mechanical component. Putting electronic component together and mechanical component together allows you to build a robot. Let me break it down for an instance. We have electronic components like resistors, LEDs, and the likes. Now, if I want my robot to move from point A to point B, I need an electronic motor, right?
Yeah.
Electronic motor is basically a mechanical component. So by the time you tell your electronic component to control the mechanical component, the means of communication between them is the code we are going to upload onto the PCB, printed circuit board, in which we have our microcontroller. By the time the electronic component knows the action to be performed, it's going to send a signal. I'm going to be using a lot of terms.
Yeah,
If you don't mind me. Actually, the signal we are sending happens to be an analog. But by the time you see them working, happens to be a digital signal. So there's actually a component on that actually convert analog signal into digital signal. By the time this conversion is done, you just see your robot start moving from point A to point B.
Oh wow, that's interesting. The reason why I asked that question is that there are a lot of viewers out there who are not familiar with all these terminologies that you are using now. So that's why I try to break it down to a layman's understanding. Yeah. So if that works, that means they already get the information you are trying to pass. Yeah. So thank you so much for that answer that you just gave us now. And from what you just mentioned too, we also know that there are various industries in out there that AI and robotics has impact on. So which of them do you think robotics and electronics has biggest impact on?
Currently now, in a global world now, we have challenges about agriculture and likewise health. But let me be very brief about them. For an agriculture now, we have a lot of food shortage, and that happens to be a lot of farmers doesn't have the necessary tools in order for them to farm. And basically, we have different electronic gadgets that can perform that, different robots that can perform that. But for us to use those electronic gadgets or robots to maximum satisfaction, we need to include AI into them. And you know that an artificial intelligence, adapting it or integrating it into a robot makes the robot to actually perform very well. An humanoid robot that looks like human being can be deployed into a tomato farm. What is it looking for? In front of the humanoid robot, it's just going to scan which of these tomato is ripe, which one is actually unripe. We know that unripe tomatoes are actually green,
Yeah,
and we know that the ripe tomatoes are actually red
red.
in
Yeah.
color. So basically, we use a color sensor that can actually differentiate between red color and green color. And by the time it sees red, it's going to plug it. And by the time it sees green, it's going to do what? It's going to leave it. So basically, an AI allows us to do that because it can actually scan and actually harvest. So with that now, integrating AI into robotics for agriculture, we actually maximize food production in Nigeria and in the world at large.
So what you're trying to say right now is that AI and robotics coming into the agricultural sector is going to increase the productivity of agricultural products we have in Nigeria, right?
Absolutely.
Wow, that's interesting. So, Mr. Stephens, what would you like to say about this?
Yeah, I like the idea you brought about putting using this robotics in agriculture.
Yeah,
But from my perspective, I talk about security.
yeah.
I also see the way he's talked about security, the robotics now and security, they meet at a gap where we can use robotics and cybersecurity to create a sense of security.
Okay.
Like people use drones now, they use drone to patrol and make sure things are secure.
Yeah.
IoT devices too are part of robotics.
Okay.
So I see us using robotics and cybersecurity to close the gaps in cybersecurity. But I would like to ask, do you think that we can do that in Nigeria?